Bismillah ar-Rahman ar-Rahim. Alright class, Assalamu alaikum. Welcome to EE 382, that is electromagnetic fields. My name is Dr. Abdurrahman Javed and I will be assisting you guys in learning this very crucial and very important course. So for today's first lecture, this is the outline that we are going to cover. Basically, we have got 12 points which we would cover here. So, but before delving into these 12 points, I would like to quickly go through this, the administrative issues of this course, which is actually also has been shared with you on the Google Classroom platform. And mainly there are three administrative things that you should know about this course, and they are: number one, CLOs and PLOs. So exact statements of the CLOs are given on the Google Classroom platform. I would like to just point out that there are two CLOs, CLO1 and CLO2, and both of these CLOs are related to PLO1. All right, so since you are fourth semester students, so I'm sure that you all know the meaning of all these CLOs and PLOs, so I'm not going into much details about what CLO and PLO means. Anyway, the two things which you should understand is that the CLO1 is related to electrostatics. What electrostatics is, we will know shortly, and the CLO2 is related to magnetostatics, right? And PLO1, both CLO1 and CLO2 are related to PLO1, and PLO1 is nothing but engineering knowledge. All right, knowledge. Okay, so by this fact that both the CLOs are related to one PLO, and that is PLO1, the fact that there is only one fundamental PLO is associated with this course signifies that, or highlights the very nature of this course as well, that this course is of fundamental nature, and that this course is actually providing foundations to many of the other advanced courses as well. You would rarely see this combination where more than one or all the CLOs are associated to one PLO. This is administrative issue number one, I would like to call it. Administrative issue number two, which may be of interest to you all more than anything right now, is sessional marks. Sessional marks. We all know that sessional marks are total 40, and there are two schemes, and these schemes are the one which I have defined to evaluate you all throughout this semester regarding these sessional marks. Number one, if the university administration decides that midterm is compulsory, by now you should understand that as for now midterm is compulsory. But if I'm able to win over a situation in which I can skip this midterm, I would then give you 3 assignments. So in that case, the sessional marks will be based on 3 assignments, right? And if the university administration or the department's administration decides that midterm is compulsory, in that case midterm will carry 20 marks and assignments will carry 20 marks. That's it. That's all I want to talk about sessional marks. The assignments are well defined and they are associated with a particular week. At the end of a particular week, you have to submit the assignment, or at the end of a particular week, you will be given an assignment and you will be given a specific deadline for that, and you must submit your assignments then and there. No late excuses, and if someone misses that deadline, obviously he or she should expect some reduction in marks as well. So this is my favorite scheme for allotting you sessional marks, that if midterm is not necessary, if I'm able to convince my administration that I want to skip midterm and they all agree, then we'll go for 3 assignments, right? And the breakup of the marks for each assignment will be discussed or communicated to you all later on. But if the administration insists on midterm, then in that case scheme 2 will be followed, and in that case as well you should expect midterm somewhere in 7th or 8th week, and assignments will be again defined, definite, well designed. So you will be given assignments in a certain week, and you will be asked to submit your assignments in on a certain date. So you should all look forward to this. One more thing, there is no compensation. I have to handle more than 200 students alone. So if you miss anything, if you miss an assignment deadline, you missed it. All right. If you miss the midterm, there is no remed or no compensation whatsoever. So you must be on your toes, and you should and you must meet all the deadlines. So this is administrative issue number 2. I've talked more on that than I planned actually. All right. So administrative issue number 3 is textbook. Yeah, textbook. These are the things which are normally talked about in the initial lectures or in every course, but I don't want to waste time discussing a lot on that. But you should understand that there is one book for your text, which is written by William Hart Height and John A. Buck, and the title is Engineering Electromagnetics. All right, so you should consider this as the textbook. This is the one which is recommended by the university for you to buy or take from the book bank. But there is another very interesting and very, very helpful book by Nathan Ida. This is not a reference book. This is the style of writing of this book is again is actually the textbook style. So the Nathan Ida, and the title is the same, Engineering Electromagnetics, and a recent edition is the 3rd one, which was published in 2015. The textbook number 1, which is William Hart, you can take 6th edition, 7th edition, and I know that 8th edition is also available, but personally I did not like the 8th edition. It is actually the adopted version. Some Indian author adopted the original book written by Height and Buck. So I did not find that book that convincing, at least for me. I'm not taking any credit out of it, but I did not like the style in which they presented their text in 8th edition. So I would recommend taking 7th edition if possible. 7th edition is from somewhere somewhere from 2007. I mean, it was published somewhere in 2007. If you don't have access to 7th edition, you can take 6th edition. You can take the ebook, right? I cannot promise, and I won't promise to upload any e-version of these books because this is against the copyright laws. However, the second book by Nathan Ida, which is essentially this covers essentially the same subjects, but is very thick as compared to the William Height one, because Nathan Ida, this book explained each and everything in more than a paragraph, which this book, the first one, explained in a couple of sentences. That makes this book very heavy and thick. It's about like more than 1,000 pages textbook, and this is about 600 or 700 pages book. But this is your textbook, and this is a textbook which I recommend you to take. And the good point is that the soft copy of this version is, this textbook is available, and that soft copy is provided by the publisher itself, so there is no copyright infringement. So I would urge you all to take this. I will try to upload the soft copy of this book, and you should read this book. It's very interesting to read. However, the university adopted textbook is William Height. That's it. These are the three major points which I wanted to talk about. These are the administrative issues which I don't like to talk about in this course, because first and foremost is that the course is of 2 credits only and is very heavy to waste on these things, these administrative issues. But these are the things that you should know at least. That's the reason why I just took about 10 minutes to discuss all these things. All right. So although the credit hours associated with this course is 2 plus 0, no credit for lab. There is no lab associated with this course. And 2 credit hours of theory means you have to take 40-minute lectures. You have to listen to me for 40 minutes every week. But apart from this first week in which you will listen to only 2 lectures of 40 minutes or so, inshallah, from second week I'll be uploading 3 lectures, 3 video lectures of 40 minutes each, about 40 minutes each. And I would expect you all to listen carefully to those lectures and then discuss the issues or any confusions that you might have while listening to the lectures or reading your textbook. I would like you to all to discuss those issues in the subsequent weeks live session, right? So the live session of this video lecture will be somewhere on, I think on if I'm not wrong, 9th June will be the first live session for the lectures which will be uploaded for this week. All right, so let's get to the subject, what EE382 is. The title suggests it is electromagnetic fields, and I would like to describe this as one of the most interesting subjects that you would ever take in your 4 years program. It is a perfect combination and an intense combination, and one of the most interesting combination of physics and mathematics. So you should expect a lot of physics, a lot of mathematics, but the use of heavy use of mathematics should not lead you astray and confuse you that this is a mathematical course or mathematics course with no application or implications on the real world. No, it is not. The fact of the matter is that electromagnetic fields, the whole course was developed experimentally, physically, and then it was translated into its equivalent mathematical form or expression or equation. For example, Coulomb's law, for instance. Coulomb's law is based on physical experimentation which Coulomb's did, right? And then later on, that the results of those mathematical result of those physical experimentation, the results of those experimentations were then transformed into mathematical expressions which involved vector algebra, all right? So which involved vector equations, all right? So it does not mean that okay, it's easy for us to play with electrostatic situations or the cases in which Coulomb's law can be applied. It is easy for us to play with those situations in terms of mathematics rather than, you know, re-emulating the experiment all over again, right? So it is always better for us and easy for us and useful for us to give some mathematical meaning to some physical experimentation or physical results obtained from some experimentations, and give those results some mathematical meaning, and then play with that mathematical meaning instead of re-emulating, which is not obviously practical, to re-emulate the physical experiment every time, and it does not make any sense actually. So what you would see here is that we will start off with a basic fundamental experiment. We will try to understand that experiment, and then we will try to give that experiment a mathematical meaning. We will try to, in other words, we will try to find out some mathematical expression which relates to, or which describes in the most perfect sense possible, describes the experiment which was originally performed, right? And then we will try to generalize things to you know, apply in different situations. So first of all, what the field is, right? What the field is all about. The contents in this first week, I would not try to be, you know, very much technical and all, but I will try to appeal to your common sense, to the physical knowledge that you have, the knowledge of physics that you might have acquired so far from your from your matriculation physics or from your intermediate physics. I will try to appeal to that. I will try to make sense out of it in the first week, right? So I will not start the you know, chapter number 1 right away from here. I will try to build certain foundations on, and I will try to motivate you why we should learn this course, inshallah, and then we will you know, start chapter number 1 probably from next week, or maybe from next lecture. It depends that how much we cover in current 40 minutes. By the way, on the right hand side you are looking 1:1. This first one is the number of week, and the second one is the number of lecture. So today is first week and first lecture 1:1. Next lecture should be 1:2, and the first lecture for the second week will be 2:1, and so on. So what is field? Let's try to discuss that. Field is mathematically how field is defined. We will try to define everything in terms of mathematics and in terms of physics as much as possible, wherever possible. All right, what is fields? Let's try to break down this title of the course, and then we'll be able to better relate what we are actually going to do in this course for next 14 weeks. So electromagnetic fields. So the term fields, let's break it down. Fields. If I just translate the meaning of this fields from English to Urdu, it means Maidan, an area in which certain things happen, right? A bounded region, Maidan, right? So field is a bounded region in which something happens. Maybe football field, a bounded region in which football is played, right? And then maybe battlefield. Okay, so battlefield, a bounded region in which battle is being is being done or is carrying along. So fields, whenever the word field comes, the word field should give you a bounded region. It can be a two-dimensional region, it can be a three-dimensional region, and it can be a one-dimensional region, which is of course theoretically important but not practically. So whenever you listen to the word field, there should be some bounded region comes to your mind. Secondly, this is the physical definition. There is something important about that field. Something is happening in that bounded region. That thing is also important. If nothing is happening in that region, in that bounded region, then that bounded region is just a bounded region, a three-dimensional or two-dimensional space. If nothing is happening there. But if something is important is happening there, like for example, I just said battle is happening there, so you will name that bounded region battlefield, right? If football is happening there in that bounded region, you would name that bounded region football field, right? So the crux is the bounded region is not important alone. It is very important, but it is not important alone if there is nothing happening in that bounded region. If there is nothing happening in that bounded region, means that it's just a space, right? Two-dimensional or three-dimensional or maybe one-dimensional space, but nothing important is going on over there, right? But if something is going on over there in that bounded region, then that bounded region, whether two-dimensional or three-dimensional, is a field, right? Okay, so this is my favorite example. I always give this example. So let's say we are looking from a satellite. Let's say this is maybe 1200 or 1300, the year 1300, right? And there is some bounded region, a battlefield is there, right? A battlefield. In this bounded region, a battle is taking place, so we will call it battlefield because this is bounded and battle is going on over there. So it's not just a bounded region, but something is happening over there. All right, so what you should expect, we are looking from the top, आसमान से हम देख रहे हैं, we are looking from the sky onto the earth, and there, let's say this is a bounded region over where the battle is happening, and let's say there is an imaginary line, and here we have got army number 1, maybe Artugrul, just kidding, and army number 2. Okay, so maybe there are, let's say these dots represent soldiers. Okay, army number 2, right? And this is the middle dividing line. All right, battle is not started. All right, let's say at time t is equals to 0, the battle starts. So before the battle starts, this is the battlefield. All right, you should know that by now. But there are few things which can be measured here in this battlefield. What are those? Let's say what are the common effects of a battlefield? What are the common emotions going on over there? Maybe you would say in the battlefield, the effect of battlefield is fear, khauf. Maybe you would say that no, there is an element of valor, bahaduri, you know, the dots or the army personnel over here, they are obviously, you know, they have courage and, you know, valor to stand over here and fight the face the enemy. So if we decide to measure any effect, let's say fear, right? So maybe the fear in this soldier is higher, and this soldier is higher, and these soldiers, all the soldiers in the front row, the fear is higher, and the fear of death, of course, or the battle, the fear inside the hearts of the soldiers on the second row may be a little lesser as compared to this one, right? And the fear in the hearts of the soldiers at the very end will be minimum. This is common sense, right? This is common sense. One can argue that maybe, all right, if we talk about the valor, let's say we have a meter which has a scale on it, and this is V is not for voltage, this is for valor, for example, and this is 0, means if the pointer is here, meaning the soldier has got no valor, no bahaduri in him, and let's say the other is 100. So if the pointer is here, it means that the soldier has got 100% valor. He is invincible. So let's say we have got two leads. This is all hypothetical, obviously. I just want to give you an example in order to intrigue you, in order to explain what field actually means. So so far we know that there should be a bounded region and something important should be going on in that bounded region. If this is so, two conditions are met, then that bounded region is a field. Now what we are doing, we are at different points in this field. There are different soldiers because we are talking about battlefield. Now we have taken a magical instrument based on very advanced electromagnetics and which can measure valor. So what we are doing before the battle starts, we are taking this probe, and we are touching this probe across a soldier, and the pointer tells us how much valor this soldier possesses. Okay, so maybe the first one, those who are standing on the front lines, they obviously have got the highest valor. That's why they are standing in the front lines. Let's say all these have got valor level of 100%. So if we measure the valor of the men on the second row, let's say these guys have got 95, somewhere 94, maybe somewhere 96. Okay, and all those who are maybe cowards are standing, not cowards, just kidding, at the very back. Right? So you can see that okay, this is a battlefield, but what you are measuring, the effect of this battlefield which you are measuring makes it a certain type of field. All right, this is battlefield. But can I ask you, is this a scalar field or a vector field? You can say we don't know. Obviously there is no scalar or no vector is there. But if somehow I say, all right, valor is something, you know, we call it in Urdu bahaduri, all right, jazba, josh. Is it a vector quantity or is it a scalar quantity? According to your, if that should be measurable, let's say if valor is a measurable quantity, how would you measure it? How would you classify it? As a scalar quantity or a vector quantity? Definitely a scalar quantity. You never say that I am a very brave person in the direction of east. All right, you always say that he is a brave person or he is a cowardly person. You never say that he is a cowardly person in the direction of south. Obviously direction is not important over there. So let's say this valor is a quantity which can be measured somehow, and we just discovered that this quantity valor is a scalar quantity. Now this battlefield, if we are measuring valor, becomes or can be classified as a scalar field, right? And let's say we have another meter. This is not frequency meter, this is fear meter. Khauf kitna hai? And let's say 0 and let's say 100, and again we have got two probes, and if we touch these probes across the soldier, and then the pointer will tell us that how much fear this this soldier has got in him in him. So if you are measuring fear, maybe the one can argue that those who are in the front are fearless, so there should be, you know, zero fear, and those who are at the back, let me measure the fear over here, not here, otherwise it will be mixing up. So those who are in the front have got zero fear, and those at the back maybe have got some degree of fear in them, right? I'm not talking about units, 60 units, something, some fear. Obviously fear cannot be measured in kilograms or degrees centigrade, so we are not discussing the units, we are just discussing the concept of fields here. So now if I asked you that, all right, earlier we were discussing, we were interested in measuring the valor. So what was the type of this battlefield? What the class? How would you classify this battlefield? If we are interested in valor, you would say that this battlefield is a scalar field. Why? Because the effect which we are interested is a scalar quantity. And same fear. You never say आज मुझे डर लग रहा है in the direction of south. No. Right? So because fear is a scalar quantity. If it were a measurable quantity, it would have been a scalar quantity, right? But there is some other things which we can measure in this battlefield. Let's say the battle starts and we are in this regime of time. The battle starts at time t greater than 0. What happens? Soldiers start to move in this direction. Okay, this is what happens. So now if after battle starts, if we are interested in knowing the velocity of each and every soldier after the battle starts, in which direction and with how much speed that soldier is moving, that gives you the velocity of each and every soldier. right? Maybe those who are at the back may flee. All right, so this is something which we can measure. We don't need any specialized hypothetical equipment for that. We just need the speed and the direction, and it will give us the velocity of each and every soldier. So the battlefield is the same, right? But now we are interested in what? We are interested in vector quantity, which is velocity. Now you would say that this battlefield is a vector field. Why? Because the effect in which we are interested is a vector quantity. So in a nutshell, because it's a very important concept, that's why I want to repeat it over here, that a field is essentially a bounded region in which something is happening, some important event is happening. Let's say in the case it is battlefield. All right, it is battlefield, but there is some effect of this battlefield, and if we are interested in certain effect which is a scalar quantity, then this whole bounded region becomes a field which is a scalar field. And if the effect in which we are interested within this bounded region, battle is going on, but battle is something not quantifiable, but fear can be quantified hypothetically. Battle is happening or not happening, it's just an event, right? It's just an event. It's happening or not happening, but it's not an effect. Effect is what? Valor is the effect. Fear is the effect. Velocity of each soldier is the effect of that battlefield. All right. So if that effect is a scalar quantity, this whole battlefield becomes a scalar field. If that effect is a vector quantity, then that whole battlefield becomes what? Becomes a vector field. Let me give you another example. Let's say we have got a field in which something is being grown. Let's say wheat is being grown, gandum is being grown. All right, let's say this is a field, this is a crop field, this is a wheat field. So if it is a wheat field, it should be bounded, and there should be some plants on which the wheat is being produced. The peasant has worked worked very hard to sow the seeds, and then the seed germinated, and then those germination then turn into tall plants, and the fruition is now happening. So wheat is being produced here. So all right, so some important event is going on within this bounded region. So we will say that, all right, this is a wheat field. A wheat field. Okay, गंदम के खेत हैं यहाँ पर. Wheat field is going on. Wheat is being produced over here. So all right, it's a bounded region, and some important event, that is production of wheat, is going on here. So it qualifies for the definition of fields now. So how about if it is a scalar field or a vector field? It depends on which quantity we are interested in. Are we interested in? If we are interested in the number of grains, गंदुम के दानों की तादाद में अगर हम interested हैं, if we are interested in the number of grains which are there on each plant, each dot is representing the wheat plant. If we are interested in the number of grains on each plant, then you know that the number of grains is a scalar quantity. Maybe on the first plant there are 1000 grains. गंदुम के 100 दाने हैं, 100 grains are there, and on the second there are maybe 200, on the third there are only 50, for example, on the third there are maybe 1000, 2000. So as you move along, there are different number of grains being produced on different plant. Since we are interested in the number of grains, which is a scalar quantity, then it means that this whole wheat field is now a scalar field. All right, but if we are interested that okay, for every time I want to know that when the wind blows, the हवा चलती है यहाँ पर, when wind blows, in which direction each plant moves, what is the velocity of each plant moving. So if I'm interested in that velocity, all right, so that we know that the effect now in which we are interested, although the field is the same, wheat field is the same, but the effect has been changed. I am no more interested in the number of grains which are being produced by each plant, but I am interested in the way each plant is moving if a wind passes through. In that case, the same wheat field will become a vector quantity, a vector field. All right, so I think I should stop here, and I will meet you in the next class, inshallah, and we will discuss about this a little bit further, and then we will move along. All right, see you in the next class.